Actually, I'm trying to use the same links, but it tells me that I cannot access the files.
Okay, so I'll share later on. Then probably I'll just share my screen.
Maybe, yeah, but maybe we can share an entire folder that we can use to upload our data when necessary. Maybe it would
Okay,
be
absolutely. I
maybe.
mean, yes.
Marco, did you receive an email?
Yeah, now yes,
Yeah,
can
yeah,
see.
okay. Yeah, if you click on like go to the item, then you can have
Yeah.
access. Yeah, okay.
Okay, great.
Okay. Okay, so let me show you the screen then. Because I believe Excel today I have two parts to present, actually three parts to present you. One part is the Google Maps with all the nests and the mics. So we can think about the social networking, as last time we spoke with Marco. The second part is to give you the general idea of the analysis I've done on the Excel files and like why like I guess I and Vanessa chosen the um, specific competence level. And the third part, I started to work on the model and also just trying to understand the framework. And then that will be three parts of today's meeting. But anyway, let me go to the first part because it's the easiest one.
Okay.
Okay. Okay. So that's the map of the oops, of all nests. Like you see, like in here we have labels. That's the audio mic. That's the name elevation, and that's blue. That all mics audio, and red that all it's all nests. And this is nest. That's the name, when it was found, 240604, and the elevation. So basically, to give you more idea about it, I'll give you the real understanding where we are. So that's, and also I have all the speaks. So I'll just give it to you. There's a photo. Okay. So so the nests are all right here in this area. That's one view, and another view, just to give a general idea. And this is another view. Yes, and all right here. I shared the files. I just copied that. So like, if you open up the um, pictures I sent you, I just marked where all the nests are. It is approximately just to give the idea. So like we understand like that's a small piece of area where all this experiment is taking place. So basically, it could be oh yes, and that's east view, and that's the west view. Yeah, so it's right here. If you go back to the yes, that's the river, and basically that's some humans, and this is the nest. So probably we can work on the social networking based on not based, but taking into consideration the locations of the nest and the area mass. That's it. So that's what I wanted to show you because last time I showed that kind of map to Marco, and it was just like yeah, like a very Python map. Yes. So just like yeah, like that, and it actually mm, quite similar to the Google map. So we can compare. It shows look quite similar. So you see like the low elevation, the medium elevation, and the high elevation. But anyway, so I can work more on the social networking on the graphs and try to put any connections like for possible social networking within these birds. That's the first part. If you have any comments, just let me know.
Yeah, I think the challenge is understanding the the connections between one node and the other. So, for
Yeah,
example, understanding the flows from one mic to the other.
yeah,
Okay.
probably. Because like you see, like here, like we have one mic, right, and like a lot of nests. So
Mhm.
probably it will be not only nest of the Hume's Warbler, like the species we are working on, but also some other species. So and this is like you can understand. So this is elevation is 3481 for the nest, and the mic is 3483. So it's very close. And
Yes.
probably you can get a lot of um, audio signals. And this is, but
But
this is. Go ahead.
no, for example, something that we can do, even without the graphs, because we don't have the connections, is
Okay.
simply studying the correlations between the microphones. Because imagine this map that you are showing has kind of a heat map that shows for each of the timestamps in a day, for example, how
Yes.
many birds there are in that region that we
Mm-hmm.
identify with a microphone so that we
Yeah.
can understand which are the regions in the space we are considering that are more active within different parts of the day or the week or the month or the year. I don't know.
It's actually 5 months, but basically it's 3 months of the observations. So like
Yes.
three months is like yeah. But yeah, definitely yeah. So like the timeline can be different. Like yes, hours, days, probably not because there is no different. Not, but I'm not. There is not like obvious correlations between like days, but months absolutely yes. And time, like they are used to saying like more at 5, 6 a.m. Than at 4 or 8 or 9. And I'm gonna show you. Yeah, so yeah, that's the first part. The second part, okay, we can just go to the preliminary analysis. Okay. So I define the functions. That's the visual data just to get general information. Actually, we can do that's duplicates, missing values, some statistics, and plotting the histogram, heat map as well, and trying to find the uh, multicollinearity within the features. That also the actually this function is not working well, but I'm trying to make sure like it's working well. So like trying to understand like who's singing before and after Hume's Warbler within 3 seconds window. Another function is to understand for catching song, like a sound of the same species that is longer than 3 seconds, and it gotta be continuous. Oh, continuous. Okay, I'll change it to little. Then this is function to explore the data set, just unique values and value counts, but by the percentage, not by the numbers absolute, but by the share. This is the function to. I called it accuracy, but in fact we just counting the mean average of the whole data set. So the main idea behind it is, let's say the confidence level is 0.5. So, and we're trying to understand like what is the average mean of all confidence levels, not confidence levels, but all the probabilities for all the observations, including habitants and non-habitants. So in this case, we understand. So let's say it could show us kind of the accuracy of data set. If under 0.5 confidence, we can get the average mean of 0.75. So we kind of assume that within this confidence level, at least 75% of all the species, habitants and non-habitants, are predicted accurately, and 25 is off. It's just like an assumption, because Annan proposed us defining the highest and the lowest level, like boundaries. It also could work, but to be honest, don't really understand how we can use that accuracy assumption to define the confidence level to work with. But just give me the ideas, and we definitely can work from there. So this is defining the groups of the birds that are in the same outer chunk. Let's say like three. We have some birds that are captured within same 3-second chunk. So that's the all data we had. So that's pre-processing data, and the notebook is not done yet. It's very raw. So like I dropped some columns because like we have common name and scientific name, which is all the same for the analysis, and year because it's 24. And this is yeah. So and I split up the data set into 5 different data sets with different confidence levels. And actually, accuracy, or in fact, it's mean average.
Just a comment on the splitting. You are not actually splitting, but you are considering multiple categories. I mean, when you take the elements with confidence levels higher than 0.6, you are including also the ones with confidence higher than 0.7,
Yes.
0.2, etc.
Yes.
So it's
Right.
not like you are dividing
Split,
it
yes,
in
it's not
groups.
So it's like yeah, grouping, I guess. Okay.
Yeah, it's okay.
Yes, absolutely. Yeah. So yeah, right. It's not splitting because I have to split. It's like you have to make sure like the boundaries are like strict. But yes, it's grouping exactly. And so and here we're just printing the accuracy, which is not accuracy, but the mean average. I can change it. Doesn't matter. So like and let's say for data like with confidence level 0.5, the total mean average is 0.756. For habitants, it's 0.77, and for non-habitants, it's 0.697. So like, and just like to understand like what is the mean average for all the probabilities within the data set and within the habitants and non-habitants.
It would be good to have also the support. So how many birds are there?
Oh, okay. So you mean like the absolute numbers? Okay, absolutely. Let me just.
You can print simply the length of the data frame. And
Yes, I have it actually. I have it. Yes, exactly.
Okay.
That's right here. That's what
okay.
Yeah, so I'm just showing. Yes, absolutely. So this is like what total yeah by and I have here like the numbers. So here we see like the total numbers of all the birds and the habitants and non-habitants. And the main idea behind it is kind of see on the plot like the elbow plot, where we can try to figure out the speed of changing. So in this case, when the speed of change is slowing down, that point could be probably the best trade-off for us to pick the right confidence level. But here we don't really see, and so this is the numbers. I can actually like add it up like some like total evidence, non-evidence if needed. Okay. Easy. Okay. Yeah. So this is the first one. Okay. Okay, doesn't matter. Yeah. So this is the total numbers of the of the numbers of all the total inhabitants at different levels. Yes, here. So I was just trying to see like the absolute and relative differences, but it didn't actually give me any insights. So this is so I also build up the plot for seeing how the absolute numbers of each category, each class is changing, and also the share, like value counts by percentage, is also changing for every class. So like we see, like if for the non-habitants, the share green is going down with every confidence level, while the evidence is going up. So it means with every confidence level going up, the share of evidence is also going up. It's just to understand the visual. And in this case, probably that's the case where we decided to pick up confidence level 0.7. This plot shows the mean average of the total data set, or we call it accuracy. So like we can see like the mean average is going up with every confidence level. And at the same time, the share of habitant, it's kind of meeting at 0.7 confidence level. So we decided at this point, the influence of non-evidence, it is the minimal for the total for our data set. And we picked up 0.7 confidence level at this point as a trade-off. But to give me the ideas, maybe I should use another technique to understand or to decide which confidence level to pick up, or maybe like go like a little bit deeper for the analysis. So that's kind of the decision maker plot for us. Yeah. So
can you go up to the previous picture? Yeah, like one of these. Okay, that's fine. So I think you said you're trying to, or you're trying to understand this picture better and see if you can find, for example, a kink point where you have a like curve that looks like this, and you want to find this point, etc. So
Yes.
the issue here is that your horizontal axis is the confidence level, and that is your control variable. And that variable, you don't know anything about the confidence level, right? So the confidence level we've seen before, it's very mysterious. And so basically what I'm saying is that you can, or the designer of the BERT net can just simply rescale the confidence level, and your picture, your curve will look like completely different. So the thing we can do is that instead of plotting the count against confidence level, we can plot some like two dependent variables, or two things that we cannot control. So for example, if you plot the count against the accuracy you have there, then that might be more informative than this picture here. Because for this picture, you can just rescale the confidence level and your curve will look like completely different. So instead, if you like plot the count against the accuracy, then it doesn't matter how you scale the confidence level, you always have the same curve. And that curve might be more informative than this one.
The count like total count and evidence and non-evidence, and just so like we got four lines, right? The accuracy and the absolute counts.
Right.
Okay, good. Okay, I'll do that absolutely, and I'll give you the okay.
But in general, now, whichever choice we make, I think the approach is quite good. And in general, simply we will need, I think, to test the overall model that we will create, our overall architecture with different thresholds in order to study them. So it's okay that now we choose the threshold that we consider the most appropriate, but
Yes.
we will need to do experiments with all the thresholds, with the overall workflow that we will define.
Okay, I got you. Okay, so I'll just let me go like through the first analysis. Yeah, probably that's a good idea, Annan, and I'm gonna like go deeper, and then we will see. So look, probably
Great.
it will be not 0.7. Yes, because I'm gonna work on the plot. Just don't wanna waste time, even if it's a few minutes. And then we can choose the confidence level based on that plot and select the and this plot. So like and in our case, so like we decided to go with the 0.7 confidence level. We just we dropped all the non-evidence because it's not valuable, and so like ran the visual data function, like yes, just trying to understand like the statistics, like so like we see the time, like for the month it's like yeah we got like from May to August, and we see like the most observation we got in June. Then time is from 5 to 7 a.m. Almost no one at 4 a.m. and just a few at 89. That's for data set. And the latitude is like from like, let's say 33.142 and up. And here is just like between 7645, 457. Yes, and the elevation it's basically a low elevation with some spikes in middle elevation. So there's the matrix for the correlation. So exploring the data sets, just it shows us on the same picture but with the numbers. And this is the summary for total for the data set based on confidence 0.7. So we have that number of total observations, total number of all birds with top 3 birds, and seeing that the greenish warbler, another species, it's making up to 82% of all the observation. Yeah, so I'm sorry, not 82, but 3 of these birds making up 82% of the total observation. And the most common bird is Western crowned warbler, followed by Humes. That's our species. So most observations are in June between 5 and 7 a.m. Elevation and the latitude. And this is like the latitude doesn't speak to us itself. So I put the miles to understand the how big or small is area, and it's very small. So in this case, we also try to understand the data of the Hume solver. Yeah, same approach, and that's what the data says. How many observations we have, but Hume solver is actually observed at mid elevations. Despite the general data set, it's more about the low elevation. And it tends to sing between 6 and 7 a.m. With slightly fewer observations at 5 a.m. and also about the latitude and longitude. Then we explored the songs, continuous intervals. Yes, and also, yeah, I was trying to understand because I saw the data like the some birds are singing quite a lot, so I was trying to see like who's the champion and just like set up the duration more than 99 seconds. It can be different number, but I just decided to go to 99. Probably it's not the best approach, but anyway. And let's also try to understand like the continuous songs of Hume's Warbler as well. And that's what we got. So like a total of 1,500 observations for birds that think more than 3 seconds. The average duration of the song is 9 seconds. And the champion is like, I guess it's gotta be. The champion is resting ground Warbler, and specifically that's PSL10 Nest. So not Nest, but the microphone, and he has 7 instances for more than 108 seconds. So that's a lot. And even like singing nonstop for almost almost four minutes. And we also got some information about Hume's Warbler, and his maximum duration is 69 seconds, and 1/3 of his songs were recorded within. mm, Actually, it's not feet; it's meters. Within elevation of 3,570 and 72 meters. So this function is not working well, to be honest. So I'm trying to understand like what's wrong. And then we're exploring the birds who are interacting within same 3-second chunk. So it's only 1,300 observations. And it's exploring. So we can see 1/3 of the all like 1/3 of all the chunks has at least Hume's Warbler. So and also I was trying to understand like the pairs. As we can see right here, like Hume's Warbler is used to interact with Himalayan bluetail 319 times out of 1,000, 1,500, and that's the pairs. And also, I was trying to get idea only with the Hume's Warbler. So we see like the interactions of birds in this area. That's it. Do you have any comments? So like maybe I have to adapt something or like make it a little bit different.
I think this is pretty comprehensive. Uh, I, we can. Have you discussed this exploration also with the domain experts?
Not yet because we supposed to discuss it last Friday, but both of them were out.
Okay, but for example, something it might be interesting, but I don't know if it's actually interesting. So before doing it, I think you would have to talk with the domain experts.
Yes,
For example, the interactions that you are studying here
yes.
might be related to time. Okay, so it would be nice to show in a paper, for example, how the interaction changes with time. So
Okay.
imagine the numbers that you are showing here and how do they change between 5 a.m. and 6 a.m., 6 a.m. and 7 a.m. in multiple bins. And yeah, but I
Okay,
don't know
okay.
if it may indicate something useful for the analysis that the main experts want to do.
Yeah, I mean we can do that absolutely. Yes, absolutely. Yes.
Yeah, in general, I think that if you present your results, your exploration to the domain experts, and then you collect their questions, we can understand how to improve the exploration to make it more interesting. You know, now you're just describing the data as
Yes.
I would, okay, but domain experts might have questions that are harder to answer with our exploration, but more interesting for a paper.
Absolutely, absolutely. Mhm. Yeah, I'm just gonna send this to the experts. I mean, just try to probably meet up next Monday and see, okay,
Mhm.
how it goes. Absolutely. Okay, cool. So that's the analysis, and also so like the model. I was so like I was trying to understand like how like the other models are working, like for any sounds classifications, and found out that um, rock AUC metric could be the best uh, metric uh, together with accuracy could be the best to work on. And like just I just put down like why it can be like the best for the reasons, and also the predictions and the training data. So like in this case, that's the more if we trying to classify within the family, like so like mammals and birds, and then go to the birds. So like in our case, it's just we just go like from the species to call type and the captioning. And the main idea is like just to get the audio input, audio encoder. So in this case, that's like in what we do in the window in like 3 seconds. And for the Q former, like for the transformers, we might just use the Librosa library. That's it. So probably we just don't use the transformers in this model. But I'm not sure, to be honest. So probably I just wanted to understand. I mean, like if this case we use the Librosa library, so we don't need the embeddings. We just go straight to the prediction. That's it. But I
But
just want
wait,
to.
regarding the tasks that you have listed here, so species classification, etc., doesn't BirdNet already perform at least the three the top three tasks that I see
Yeah.
here?
So species classification, right, and family classification. It's extra task. I mean, just I'm just trying like to make sure like the model we're trying to build is scalable on like on the higher level. So in our case, we just go like with even like these two tasks, not even
Mhm.
species, and actually three tasks: species detection, because like it's gotta be Hume's Warbler, and also and other birds or like other sounds. So it is a kind of like species like class detection. I mean, in our case, yes. And then we are trying to get the call type classification. Is it a call or bass song?
Yeah.
That's it. So then we have to caption all the prediction. Prediction.
But for
Uh,
species detection, we don't need to create our own model. We already have BirdNet, right?
we do, but when we build our model and we're trying to we're trying to predict the classes. So in our class is uh, Hume Warbler and the rest of the birds and the rest of the sounds. So that's how
Yeah,
we yes.
but BirdNet gives you the species of a sound, so
Yes.
you can consider it as Hume Warbler when BirdNet says that it's Hume Warbler. Otherwise, it's another bird.
Yeah. The case is so when we build our model, we're not going to use the BirdNet. So we have to run our model through the audio files uh, we have. So in this case, we don't use the BirdNet anymore.
Why? I mean, in general, you build your own. It would make sense to build your own model to classify the species if humans had collected the ground truth. But given the fact that your current ground truth is provided by BirdNet,
Yes.
building your own model that predicts BirdNet labels, it's just like underperforming with respect to BirdNet. You are considering BirdNet as your teacher and you are a student of BirdNet, so your predictions will be worse than BirdNet for sure.
Yeah, but we are predicting only Hume's Warbler and the rest of the birds. We don't care about the rest of the birds in this case. We just have to capture the Hume's Warbler sounds.
Yeah,
And
I agree.
yeah.
I
Mhm.
agree, but you don't need a machine learning model that does this.
Okay,
It's a,
okay,
it's an if
okay,
then else clause, you know. You you give your input to BirdNet, and then if the output is Hume Leaf Warbler, you consider it, otherwise you don't consider it. It wouldn't make sense to create a model that will surely underperform BirdNet.
okay. You got it. Okay, I got it. So that's and also shall we go with Librosa or because Librosa is good. I used to work with Librosa, and it actually gives a good outcomes. Or try to go with transformers.
Uh, my simple answer, and then come in if you think differently. But the simple answer is both,
Both.
because
Okay.
transformers are, when you are publishing a paper and you just rely on MFCC features, for example, reviewers might be concerned that aren't considering the most recent literature in computer engineering, computer science, and so on. So they would ask to add transformer baselines, basically. So uh, we should, in general, have multiple baselines so that we can compare our approach and perform multiple experiments. And in general, with Hugging Face, transformer architectures are usually very easy to implement, so I don't think it would
Okay.
be a huge effort.
Okay. Yeah. I mean, it's not about like time and efforts. Just like try to understand. I can just listen to you because you have more experience, and you just guide us. I mean, me and Vanessa,
Yeah, yeah.
to make the better decisions if we were doing on our own.
Uh,
Okay,
I would I would start with simple features just to, and the very first question is which data set are we using? But in
Yes.
general, I would ask with something simple, and if this simple stuff gives us a 99% of F1 scores, then we don't need to do other things probably.
Okay.
yeah. I mean, I'm not familiar with the browser, but people are definitely interested in the transformers and they want to see how transformers perform. And I think you mentioned here that you're trying to use transformers to capture some long-range dependencies. And in terms of long-range dependencies, there are some new types of models called state space models, and I'm very interested in, and we can plug it later to see if it helps improve the performance. But maybe you can start by building a simple pipeline where you can just easily plug in and plug out some recurrent units like transformers, Librosa, RNNs, etc., so that we can easily test it with like different model architectures.
Okay. Okay. Absolutely. Yes.
By the way, when you say you try to like train this model to classify a call versus a buzz, how do you get the correct data label? Are you going to do that
Oh,
manually or?
Actually, yeah. So I actually like a few days ago, I found another database that we can use for labeling. So we do the labeling manually, absolutely. So we've got the data from Xenocanto. That's the one website. I mean, like that's for the observations of the birds. And like a few days ago, I found another one. We had like extra almost 40 observations, and we doing the annotation like labeling by ourselves, like manually. So in this case, why I was asking a lot of questions, like if we have to specify the species detection, right? Because like we have the Hume's Warbler call and buzz, so like two sounds. But in this case, we just trying try to go through the whole audio file and in the catch those two sounds, and the rest is gonna be like the third class, like just like other sounds. So like one class is like Hume's song or call, another class is Hume's buzz, and the third class, we can just maybe just keep it like other songs, or just it can be like binary classification. I'm not sure yet. Binary will be just the simplest way, like in like everything, I guess.
Sounds good.
Okay, cool. Do you have any other recommendations or feedback we have to pay attention to?
In general, I would think, I mean, make the most from the conversations that you will have with the domain experts,
Yes.
because I don't think the classification of buds versus call versus other songs would be difficult for you, because I remember that you and Vanessa have shown us the frequencies, and it was pretty clear that the differences between buds and call were
Yes.
clear.
Yes.
I don't think you guys will have to create a 1 million samples dataset to have good performance.
I wish.
But but you could we could identify classification tasks that maybe are more interesting. For example, based on what's happening in a if we think about the positions of the microphones and the nests, uh, one type of classification could be understanding if a bird, I mean, one of the nests will have more birds in a future timestamp. And this can be
Okay.
used for predictive analysis, you know. But all of this should be guided by domain experts, because
Okay.
I can identify multiple tasks that are fun and interesting for a computer scientist perspective, but maybe
Yes.
not useful in the real world.
Absolutely. Gotcha. Okay. Yeah. So I gotta speak to our experts and domain experts and ask them if that information is enough or they need something else to work on.
Mhm.
Okay. Got it.
Great.
Yeah. So I guess that's it. And yeah, if you have anything to share, just let me know.
Great. Sounds like a good pen.
Okay. Thank you, guys. Thank you so much.
Yeah.
Thank
Thank
you.
you.
Have a good day.
Bye.
Yeah. Happy
Bye
Friday.
bye.